AP. Today we're going to look at section 2.2 in your textbook. The following are your learning targets for this section. I can find the derivative using the following rules. We're going to look at the constant rule. Remember, constant means a single number without a variable. The power rule, sum and difference rules, what to do when you have a polynomial with plus minus signs, and also the derivative of a sine and a cosine function. Learning target 2, I can use derivatives to find slopes of tangent lines at specific points and then write the equations of the tangent lines. And we've done a little bit of this already in the first section, so a little bit of it's going to be repetitive. But remember, when they ask you to write an equation of a tangent line, they're wanting you to use the point slope form. Y minus y1 equals m times x minus x1. In your textbook, in Theorem 2.2, it tells you about a derivative of a constant. Notice my notation is d dx. Find the derivative with respect to x. Find the derivative with respect to x of a constant. And the answer to that will always be 0. Think about it in terms of a graph. If you have a constant function, then the line is horizontal. Like this one, I'm going to call 3. The derivative with respect to x of 3 is going to be 0 because derivative means slope, and the slope of the horizontal line is 0. That's one way to think about it. Also, dealing with like tangent lines, you would have to kind of consider the line that is touching that point, or any point for that matter, and it's still going to kind of model the same direction. Theorem 2.3 is on the power rule. Power rule is basically similar to what I shared with you in pre-cal last year. Find the derivative with respect to x of x to the nth power. You will take the power on the variable and you will multiply it, so it now will become the coefficient of your term, n times x to the n minus 1, and you'll subtract 1 from the power. So find the derivative very quickly. We'll do all kinds of examples, but find the derivative with respect to x of 5x to the 6th power would be take the 6, multiply it by the 5, if there's already a coefficient there, of course, and you'll get 30. Drop your x down, and then subtract this by 1, and you'll get 5. So 30x to the 5th. Okay, so looking ahead, we got several examples to look at just to make sure that you understand the first part, the first learning target. For example 1, it's very straightforward. The function's name's f of x is equal to 5x minus 3, and I'm wanting you to find the derivative with respect to x. Now remember, there's different ways to write the notation, but because I gave it to you in a function, instead of saying y equal, I would just write it like this, f prime x. And what you do basically is take each of the terms in a polynomial and use them separately. So you're looking for the derivative of 5x. And remember, the x is a power of 1, so technically you're using the power rule here. 1 times 5 is 5. And then you're supposed to subtract 1 from your power. Well, when I do that, 1 minus 1 is 0, of course, and x to the 0 is just 1. Okay, so there should not be an x left in that part to the answer. And then you're going to look at the next term in your polynomial, which is negative 3, and you're going to do the derivative of a negative 3, and of course negative 3 is a constant, and so the derivative of a constant is 0. And so this is the answer, the derivative for that problem. And again, this is called first derivative from pre-cal. Example 2. Function's name is g of x is equal to 3x squared plus 2x minus 1. And we are going to look for the derivative, notice the notation, g prime x, and we're going to do each term separately as I said in the last problem. So let's focus just on 3x squared. 2 times 3 is 6. Drop your variable down, subtract 1 from the power, and it becomes 1. Next, look at the middle term in your polynomial. Derivative of x, or derivative of this with respect to x, of 2x would be 1 times 2 is 2. That would be a positive 2. And then x to the 0, meaning we don't write it down. And then last, the derivative of a constant is just 0, and I'm just not going to write plus 0 here. And so that is the best answer for the derivative of that quadratic. In number 3, notice I have y equals the cube root of x. A lot of times with problems of this nature, you want to make sure that you rewrite before you actually derive. By rewriting, I'm saying rewrite it in the terms of power, so it would be x to the 1/3. So y equals x to the 1/3, and then you're going to use the power rule. Again, what's your notation? Because I didn't use a function, I'm just going to do y prime this time. And so the derivative for this function would be 1/3 x, and then you'll take your power and you'll subtract 1 from it. And so very quickly, this is how you think about it. 1/3 minus 1 is the same thing as 1/3 minus 3/3. We've got a fraction, of course, so we got to have a common denominator. And 1 minus 3 is -2, and then it would be thirds. And so it's okay in calculus to leave negative exponents. I know it kind of bothers me because I teach algebra a lot as well, so you could do this if it bothers you. You can just say 1/3, and then the x to the -2/3 would go to the bottom as x to the 2/3. So like I will take either answer. You do need to be aware that both of them are obviously the same. And depending on like the source of the assignment, sometimes they prefer it left with negative power, and sometimes the answer key will write it in this format. Okay, so either one is fine. Alright, let's take a look at number 4. On number 4, I see y equals 1/x squared. This is a particular problem where I would want, let me rewrite this really quickly. I would want to rewrite it using a, without a fraction. And so I would say y is equal to, instead of 1/x to the second, I would just call it x to the -2. Because this way you can use the power rule. When you're ready to derive, remember again to use your notation. So y prime is equal to -2 times 1 is -2. Drop your variable down and then subtract 1 from -2. And so if I do like a -2 minus 1, that of course is going to be -3. And so this is an acceptable answer. Or if you wanted to, just like I did in the last one, you could call this -2 divided by x to the 3rd. As long as you move this piece only. Because remember, -2 is raised to the 1st power anyway. Alright, same deal with number 5. It says y is equal to, and I see a 7 on top, divided by, and then this time I have parentheses around the 3 and the x. I'm just kind of rewriting it so you can see it, since I typed it. And so this is the original problem. In order to derive and use the power rule, you would want to get rid of the fraction. So since I'm not ready to give a derivative, I just use y equal. And then I'm going to write this as 7 parentheses. And I'm going to take this term and move it to the top. And that way I can get rid of the negative exponent. So now it becomes 3x raised to the +2 power. And then you don't want to give a derivative until you simplify your problem. So I'm still in rewriting mode right now, in simplify mode. So I drop my 7 down. I'm going to do a quick power rule. So this is going to become 3 squared x squared. So it's going to be y is equal to 7 parentheses, well 3 squared is 9, so 9x to the second. Okay, I am still in multiply mode. So 63x squared. And I have finally, after a few steps, made it to a place where I have a polynomial, and I'm ready to derive, find the derivative of y prime, and I can do 2 times 63, which is 126, and that's going to be x to the 2 minus 1, which is x to the first. But you can see it's taken me several steps to get there, and I do want you to make sure that you show all your steps, as always. Okay, next is number 6. We got f of x equals 1/2, and it's times the cube root of x to the second. Again, it's so much better when you see radicals to change them over to like fraction powers. So I'm going to do that now. I dropped my 1/2 down. Instead of saying the cube root of x to the second, remember from algebra 2 that the index number, which is here, that's always going to be the denominator of your fraction, and the power on your x is going to be the numerator. So it's 1/2 times x to the 2/3. 1/2 times x to the 2/3. Okay, alright, and then from here, I can't simplify anything else, looks like, so I'm ready to derive. And I'm going to multiply the 2/3 times the 1/2. 1/2 times 2/3 is 2/6, but that's better known as 1/3. So let me go ahead and change that. Drop my x down, and then I need to subtract like 2/3 minus 1. The same thing I did before. When you're subtracting 1, I always like to just think of it in terms of the same denominator. That way you can do it faster in your head. 2/3 minus 3/3. Well, that's the same thing as negative 1/3. And then I'm going to rewrite it just so I have a positive power. So the 1/3, I'm going to write like this. And then I'm going to take this x to the negative 1/3, and I'm going to relocate it, change its position to the bottom, and make it x to the 1/3. And so here's the derivative for that problem. Okay, in your textbook, Theorem 2.6 is on derivatives for sine and cosine, and these are just very basic ones, but you do have to start memorizing these, because later on we'll learn the rest of the trig functions, like the tangent, cosecant, secant, cotangent, all that good stuff. But for now, there's only going to be 2 that show up in this section, and it's on the sine and the cosine. And please notice the notation, d dx, find the derivative with respect to x of sine x. Anytime you have a sine in your problem, they're asking you for the derivative, the answer is going to be the cosine of that same variable. The derivative with respect to x of sine x is going to be cosine x. On the other hand, if they give you cosine, find the derivative with respect to x of cosine x, then they're wanting you to give the negative sine x answer. Negative 1 sine x, either way. Okay, but these they're very important, and they must be memorized. Derivative of sine is cosine. Derivative of cosine is negative sine. Okay, so let's take a look at some examples here. And there's different ways to write them. In number 1, it's very straightforward. It's asking you, don't have the directions here, but it should say find the derivative. Y equals 3 sine x. so we're going to jump right in. Y prime equals, and this is a coefficient of the trig function. You do not use the power rule, so you're not going to take this power of 1 and multiply it by 3. That's not how it works with a trig problem. So basically, when you have a coefficient, you're just going to drop it down. And then you're going to do the derivative of sine x. And from the last slide, we saw that was cosine x. So we'll just bring it down as is. And that is your best answer. Very straightforward. Number 2, y equals sine x divided by 2. One thing I like to do when it's divided by a single number is I like to rewrite it this way so it matches number 1. I like to think of it as, in terms of a fraction, that's 1/2 sine x. So if that's my problem, then my derivative is going to be 1/2, and the derivative of sine x is cosine x. And that's it. And then the third one, f of x equals 8 cosine x. Nothing I can do to rewrite that one or simplify it, so we're going to jump straight into the derivative. Again, when it has a coefficient, please just include it. And then look at this part. Find the derivative with respect to x of cosine x. And that would be, based on your notes, negative sine x. So you write it like this. And then you never want to leave a negative in the middle of your answer. It just looks weird. And so think of it in terms of, this is like a -1. So 8 times -1 is -8. And then sine x. And that is a good answer for that one. Okay, on number 4, g of x equals -2 cosine x. No rewriting involved, so I'm ready to derive. Drop my coefficient down of -2. The derivative of a cosine function is negative sine of that same variable. So we'll show that step first. And then just like I did in example 3, you're just going to multiply -2 times -1 to get 2, and then sine x. Okay, question number 5. f of x equals x plus cosine x. This one has 2 terms. When you're ready, or when you have a polynomial, you can actually find the derivative of both of these. And so you're going to do one at a time. The derivative of x is just 1, because remember, the power is 1. 1 times 1 is 1. And this becomes x to the 0 when I subtract 1 from the power. So 1x to the 0 is the same as just 1. Then you're going to look at the second term. The derivative of cosine x is a negative sine x. So I'll write it like that. And then I don't like leaving a double sign, so I'm going to rewrite this and call this 1 minus sine x. And so that's the derivative for that problem. Okay, the next thing we're going to do is take a look at writing equations for tangent lines at specific points. So writing equations for tangent lines at specific points, we have an example here. F of x is equal to x to the 4th at the point -2, 4. And let's see how this is going to look. So the first thing you want to do, remember, is think about the equation form. You're going to do y minus y1 is equal to m times x minus x sub 1. Remember, this is your slope, of course. This is where you're going to put your x coordinate of your ordered pair, and of course the y coordinate. And so -2 would go in here, and the 4 would go right there. But first we've got to find the slope. And so we're going to go to the function, which is a x to the 4th function, and we're going to look for the slope, finding the derivative. Because it's a polynomial, it's one that we can use the power rule on, really easy. So we're going to do like 4 times 1, it's 4. And then bring my x down, and then drop my power by 1 and get 3. So 4x to the 3rd. Now we're looking for a specific tangent line. This is just the general one. You heard me describe this in the last section. This is a slope that I would use for all points on this graph, but I'm looking for the specific point, -2, 4. So please notice my notation. You would then bring down your derivative, and instead of using x, you would put a -2 in x's place. Okay, so we're substituting -2 in place of x. And we're going to do 4 times, and then -2 cubed is -8. And that's going to be -32. And so that's going to be my slope for that particular problem. And I have my point. And so I now can write the equation for the tangent line. And in this problem, it's going to be y minus 4 is equal to slope -32 times the quantity x minus -2. And we never leave two negatives together, so we're going to take those out. -2 becomes +2. Okay, so there's your equation for the tangent line. Okay, let's take a look at example 2. Right now we see g of x is equal to the square root of x minus 3, and it's we're trying to find the tangent line at the point 19, 0. So we need a slope, and we need a point. We already have the point. Just jot it back down. The slope we're going to have to find. And so the first thing I notice is I see that big radical. I'm going to rewrite this into a fraction power. Notice that x minus 3 is a binomial that's underneath the radical. So you're going to think in terms of x minus 3 raised to the 1/2 power. And then you're going to find the derivative or the slope. Same difference. You're going to multiply 1/2 times the 1 in front here, which is 1/2. You're going to drop down your quantity and make sure that you have this in parentheses, because otherwise, if you don't, then you put this power here, it's going to look like it's only on 3 instead of on the entire binomial. So it's really important that you use parentheses. And then you're subtracting 1 from your original power, so 1/2 minus 1. 1/2 minus 2/2 is -1/2. Okay, and so I'm going to have to find, that's the general slope, but I really need to find what happens at 19. I think actually in this case, I'm going to rewrite it before I substitute it in and basically get rid of this negative power. So I'm now going to say 1/2, and then x minus 3 goes to the bottom. And that's raised to the positive 1/2. Okay, and now we're ready to put 19 in place of x. Find the derivative of g at the point at 19. See what happens here. -19 minus 3 is 16. And then think of this in terms of this, that's a square root, okay? So drop your 2 down and think of it in terms of square root of 16. We're doing the principal square root, so it's going to be 4. And then that's just going to be 1 over 8. And so there's my specific slope that I need to use. So I'll come back up here, fill it in. Once I know my slope and the point, then I fill it into my point slope formula. Y minus 0 is equal to 1/8 times the quantity x minus 19. And there it is. Okay, next is on rates of change. Derivative is used to determine the slope and also the rate of change of one variable with respect to the other. Again, all of this is in your textbook, so I would suggest you read through it and look at examples as well to help understand it. But when you see the rate of change, it's a different way to say slope. Derivative is used to determine the slope and also the rate of change of one variable with respect to the other. And so what they like to do is use a little bit of physics, an introduction to physics, where they talk about a function's position, and it describes as it's the position as it's related to 0, 0, which is the origin, and it's a function of time. A lot of times they'll use the notation S of t to stand for position. Instead of using P of t, they like to use S of t. When you see rate, you know from the past that's the same thing as distance divided by time. And it's kind of throwing it back to things I know you've had in the past, like simple distance, d equals RT. If you're solving for R, you would obviously divide by t. And so that's where this is coming from. Okay, so rate is the same thing as d over t. When that you hear the word average, the words average velocity, that is a change in distance over a change in time. And so delta S, distance, position distance, time. And that's nothing, none other than just using a normal slope formula. And so you'll have like whatever the y is, y minus y over x minus x. In this case, s minus s over t minus t. But when you hear the word average velocity, that is, make sure you make yourself this note, that is average, or algebra, I should say, algebra slope. So you get to, actually, you get to just use the algebra slope and don't even worry about the calculus. If it says average. Okay, and so you're going to get to use what I said a second ago, which is the slope formula that you're used to. Again, derivative means slope. Rate of change is another way to say slope. When you see or hear me say the word position function, textbook often uses S of t to describe that. The position is related to the origin, remember, as a function of time. So S would be position, t would be time. The S of t is like the dependent variable, it's like the y, and the t is the independent variable. Rate is distance divided by time, and when you hear the word average velocity, that means algebra slope, change in distance over change in time. So a lot of this you have to get used to, like the words they use, what it means, and how you're going to use that information to apply to certain problems. Finding the average velocity of a falling object. A ball is dropped from a height of 100 feet. The ball's height, s, which is position, at time t in seconds, is the position function S of t is equal to negative 16 t to the second plus 100. So we have this scenario where we're maybe standing on top of a building, we're dropping a ball, it's from the height of 100 feet, so the building's 100 feet above the ground. The ball's height s at time t is represented by this function, because of course every single second that goes by, the position of the ball is going to change. So that's why it's a function. And the reason it's s of t again is because we're talking about position. T is time, which is the x. The time will change, and the position of the ball, which is s, it depends on the time. At time 0, the ball is 100 feet above the ground. After 1 second, the ball is obviously closer to the ground. Okay, so kind of always relate as you read a problem, kind of picture it in your head, or you draw a picture, and that way you understand what the scenario is about and kind of relate it to what you're trying to find. Determine the average velocity for the time interval from 1 second to 2 seconds. So again, we're talking about seconds here. Determine the average velocity. Well, when you see the word average velocity, you need to be thinking, like I just said in the last slide, oh, she's talking about algebra slope. Okay, well, if I'm talking about the algebra slope because it says average velocity, then that must mean that I need two ordered pairs. Okay, makes sense. And those ordered pairs are going to be, and that's why I have to understand this notation, that the time, let me write this down, and I need you to write it in your notes as well, that the time in this problem, t, is the independent variable, and the position is the dependent variable because it depends on how many seconds have elapsed from me dropping the ball off the building, we'll say. So that must mean that if I know based on my reading and I can kind of think through the process, if this is my x and this is my y, and I'm trying to come up with ordered pairs, then I know that the time interval, this is not an ordered pair, that the time 1 second, I need to figure out, well, where the ball is. And after 2 seconds, same deal. I got to know where the ball is. And so before I can find the average velocity for this time interval, I need to know the height of the ball after 1 second and after 2 seconds have elapsed. So I've got a little bit of work to do, but fairly easy. I'm going to go back to my function, and where I see t, I'm going to put 1 in its place. And we get negative 16 times 1 squared plus 100. And that's going to be PEMDAS 1 times negative 16. So we'll just do negative 16 plus 100. 100 minus 16 is 84. And then don't forget what you're actually answering here. That's 84 what? 84 feet. So put my 84 right here. And then we're going to need to do that with the 2 seconds too. Now we've got to go to the position function, s of t, put 2 in place of the seconds. See what happens with this equation. That's going to be negative 16 times 4 plus 100. And that's going to be negative 64 plus 100. So I'm getting a 36 back, 36 feet. That's how far above the ground the ball is going to be after 2 seconds. Again, the question's saying determine the average velocity. So now to finish the problem, we go back and we find the slope, velocity slope. So 84 minus 36. And 1 minus 2. And we get a positive 48 over negative 1. And so that means the slope is negative 48. And the reason that it's negative is because the ball is moving downward. So it is falling. Okay, and that's what you would expect. So with velocity, make sure like when you use the sign on your answer, that's indicating what the position of the object's doing. If you get a positive velocity, then you're throwing something up in the air, for example, and you're looking at the speed and the direction. Velocity is based on speed and direction. I'm going to say that it's, again, because some of you may not have had physics before, velocity is based on the speed and the direction. So when you get a negative 48, negative's telling you the ball is falling. Well, we can tell that from the reading, but the answer should make sense. And you do have to put it in terms of this question. So what was the y? Well, the y was dealing with the height. So we got to put feet on top of my units. And what was the x? Well, it was the time. And time was measured in seconds in this problem. And so you would want to write it like this. Negative 48 feet per second. Negative 48 feet per second. Alright, and then the last thing we need to look at is finding what's called the instantaneous velocity of a falling object. And so instantaneous means that you're going, and you need to make sure you write this down, you're going to use the calculus slope. Calculus slope. Find the velocity at a single point in time requires using limits and derivatives. So if I'm asking you to find the speed and the direction of an object at a single point, then that's where calculus comes into play. Average velocity is I give you two different ordered pairs or a way to find them, and that's why we can use algebra. Vt, which is velocity, is equal to find the limit as delta t approaches 0 of, this is the same similar notation we've used in the past. You guys have used to me doing like f of x plus delta x minus f of x. They've just changed it over to s and t. Okay, so s is position, t is time. S of t plus delta t minus s of t over t. All of this, when we do a limit of this y minus y over x minus x, is going to be equal to the derivative. And I just noticed that I left out my delta symbol here. So y minus y over t minus t, x minus x, is equal to the derivative of the position. Velocity is the derivative of the position function. That's super important. Velocity is the derivative of the position function. The velocity can be positive, it can be negative, or it can be 0. The speed of an object though is always positive because speed is equal to the absolute value of velocity. This is giving you information again that deals with an intro to physics. So making sure, because I know we all have different levels probably of knowledge of physics. Position is what you start with. Okay. Velocity is the derivative of position. And acceleration, which I really haven't mentioned today, but you'll see it, is the derivative. Well, it's either, you can do one of two things. It's either second derivative of position or first derivative of velocity. You can kind of look at it either way. So position's first, velocity second, acceleration is third. And make sure that you understand this. Position, we write as s of t. Velocity, we say v of t, which is the same thing as s prime t. I'll come back to that. And acceleration is a of t, and that's the same thing as v of t, or s prime prime of t. Make sure this is clarified. S of t is position, velocity is s prime t, derivative of position. To find the acceleration, you either have to do the derivative of velocity or the second derivative of the position. And so when you see 2 tick marks, that means second derivative. Okay, so keep in mind, if they ask you any questions, word problems about speed, they're talking about what we're used, like speed in a car, okay? But it's positive, because you can't drive negative miles per hour. Think of it like that. So it's the absolute value of velocity. If they're asking you to find the velocity of an object, they're asking you two things, actually. How fast is the object going, and what direction? So it can be positive if the object's moving up, negative if the object's falling or moving down, 0 if the object's actually staying still. Position, velocity is the derivative of position, acceleration is the derivative of velocity. When you hear, last thing, when you hear instantaneous velocity, they're wanting you to consider calculus slope. Okay? Alright, so that was a long section. Several learning targets, constant rule, easy. Power rule is the one that we've used a lot in the past and in this section. Make sure you memorize the derivative for sine and cosine, and you know how to take a polynomial and find the derivative of each piece. You can also need to know how to write the equation of the tangent line. And I didn't put it in the learning target, but kind of threw it in at the end of the notes. Make sure you really understand the difference between the words average velocity and instantaneous velocity as well.